Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Skewers by Koktuslav. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. Digits do not repeat along any marked diagonal. So there are no marked diagonals. There are no repeats on any marked diagonal here. So therefore, there cannot be a repeat along here. There cannot be a repeat along here, etc., etc. For each marked diagonal, the sum of all circled cells equals the sum of digits from 1 to 9 that do not appear on that diagonal. Okay. So for each marked diagonal, the sum of all circled cell digits equals the sum of the digits from 1 through 9 that do not appear on that diagonal. So there's a certain amount of digits that will appear on the diagonal. The digits that are not on that diagonal must sum to the digits that are in the circles. Interesting. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. Well, the first one we have here are the digits. 4 digits. That means the digits not on the line have to be a minimum of the 5 other digits, right? And we know 2 digits equals the sum of all the other digits which are not on the diagonal. So that means these must be 4 distinct digits, because if you have only 3 distinct digits here, the problem is those 3 distinct digits, that means 6 digits are not on the diagonal there. Oh, well, okay. Well, yeah, we know okay, so there are no repeats along any marked diagonal. So you can't have any, so that means the 5 digits on this, that are not on this diagonal must equal what these 2 digits add up to. So that means, oh, interesting. We have another one here. So this is 1, 2, 3, 4, 5, 6, 7, 8. And this is also 8. Right? Which means a digit out that's not on the diagonal. So again, there are no repeats on diagonals. So therefore, there are 8 unique digits here. There must be 1 unique digit that's outside of it. And then 3 digits on the line sum up to what that unique digit is. So this must be 1 through 6 here. This must be 1 through 6 here to add up to a single digit. We have here, actually, this is, well, let's do this one. 1, 2, 3, 4, 5, 6 digits. So that means we're missing 3 digits here. And then 5 digits add up to what those 3 digits are. That's not very restrictive. Hmm. 2 digits add up to what 5 digits are, so that's at least 15. So this is 6, 7, 8, and 9 there. 3 digits add up to what 5 digits are. That means it's at least 23. 4 digits add up to what? We know there's a guaranteed... Okay, so 1 cannot be here because these digits must add up to what are not on this line. So 1, 2, what's the maximum you could have? You could have 17 here. So that would be 1, 2, 3. You can't have 1, 2, 4, 5, 6. So you're guaranteed on this line cannot be 1, 2, or 3, right? If you have one minimum of the digits not on the diagonal are 2, 3, 4, 5, 6, which is 20. If you have 2 on the diagonal, that means you have minimum of 1, 3, 4, 5, 6, which adds up to 19. And if you have 3 on the diagonal, that means you would have 1, 2, 4, 5, 6 not on the diagonal, which adds up to 18. So this has to be 4 through 9 here. We know one of these digits. So this digit not on the diagonal must be 6 through 9. So we're guaranteed a 1 already on this diagonal somewhere. And a 2. And a 1 through 5 is guaranteed on this diagonal. Same with this diagonal here. We have 5 digits here, adding up to what 3 digits are. 4 and 4 are adding up to the same. So 4 and 4, that means this is an odd digit, right? Because if you have these add up to the same amount that are not on the line, that is then an even number, and then 45, an odd number minus the even number must give you an odd number. So this is odd. Okay, there we go. On this line, we have 6 digits, and that means 3 digits are missing. So 3 digits must add up to what a singleton digit here is. Therefore, it must be 6 here. And the digits that are not on this line are 1, 2, and 3 to add up to the same sum. So this is 6. Therefore, this is a 1, 2 pair here. Because that means 9 cannot be on this line. So no 9, no 6. The remaining digits on this line have to be 3, 4, 5, 7, 8. Because 1, 2, and 6 add up to 9. So that means on this line are 4, 5, 7, 8, 9. Because the digits not on the line are 1, 2, 3, which add up to 6. Okay, we have 1, 2, 1 through 6 there. Okay. This is 1 or 2. Oh, that's interesting. Say this was 1. The maximum these circles could be would be 1, 8, and 9. And that would add up to 18, but then the digits not on the line would be guaranteed minimum 2 through 6, which is 20. So that does not work. So this must be 2 here. So this is 2, which makes this 1. And I think this has to be 2, 8, and 9 to be in the circles. And the digits not on the line would have to be 1 through 6, I believe. Yeah, 1, 3, 4, 5, 6, which adds up to 19, which is exactly what 2, 8, and 9, which is the maximum for these 3 digits could be. So this is 2, 8, 9. Therefore, this must be a 7 on this line, because we must be missing 1, 3, 4, 5, 6 to add up to the same sum. So this cannot be 7. This can't be 7 because of 7 in the row and box. This is 8 or 9. This is 8 or 9, so the other 8 or 9 has to be here. Right, because we know there's 1 8 or 9 along this line, there's 1 8 or 9 along this line, and there's 1 8 and 9 here, 1 8 and 9 here. That eliminates 8 and 9 from the rest of the box, so this cannot be 8 or 9. This 2 eliminates 2 here, and this can't be 1 because of 1 on the line. This can't be 1 or 2 either. So this is either 1 3 4 or 1 3 5. Adding up to 8 or 9. We are guaranteed, though, one of these two is a 3. Okay, so this, none of these digits can be 8 or 9. None of these digits could be 8 or 9. And we can't have, this has to add up again. These 4 add up to the same, to the other 4 digits, which are not on the line, so this must be odd. 2 can't be here. 2 cannot be any of these, so 2 then has to be one of these 2. We know 2 has to be one of these 3 here, then, because there's no place for it in row 1 in either of these boxes. 2 can't be here, 1 can't be here. So this is 4 digits equal the sum of 2 digits. We don't know which. Okay. Let's see. These 5 digits must equal the same as 3 digits outside of the line. Well, and one of them, not outside the line, is guaranteed to be 8 or 9. That means you can have at most 6, 7, 9, which is a sum of 22. But you can't even have that. If this were 6, 7, 9, that's missing, then you would be missing this. You can't have 2 digits there. Interesting. Doesn't this almost make this have to be 1 and 2 then? I think it kind of does, right? I don't think you can have 8 or 9 here, right? Because then that means the maximum of the digits not on the line would be 5, 6, and 7, which would be... Right. You'd have the maximum be 5, 6, 7, which adds up to 8, 9 plus 8, 9, which is already 17. So 18 and 17, and then you have 3 more digits. That's not going to work. So this cannot be 8 or 9. So this must be 8 or 9 here. That means this is at maximum 16. So you're guaranteed 1, 2, 3, 4. Not on this line. So this can't be 4. It's 1, 2, 3, 4, 6 or 1, 2, 3, 4, 5. It cannot be 1, 2, 3, 5, 6. So we're guaranteed 8 and 9 have to be on this diagonal, period. 6, 7. Can you have it without a 1? I don't think so, right? 3 digits with 1, 8, 9 cannot add up to 5 digits. And you can't even have 1, 8, 9. It's 1, 7, 9 at most. So 1 has to be on this line, and therefore it cannot be here, because on this line is only 4 through 9. This line then has to have a 1, and 1 can't be here, 1 can't be here, 1 has to be here. What about 2? If you have 2, 7, 9, that adds up to 18. That would mean this is at minimum 1, 8, 6, 3, 4. That's way too big. So this is already, yeah. So therefore, you have to have 2 on this line, which means 2 has to be here. That means this cannot be 2 here. You cannot be having an 8, 9 on this line twice, because then this doesn't add up. Because 1, 2, 3, 6, and 8 is minimum. That's the minimum. So it's 6 plus 6, which is 12, plus 8 is 20. And 5, 6, 7 at most. It just doesn't work. Okay, so this cannot be 8 or 9. It's 4 or 5. So we're missing a digit on this line of 6 or 7, 8 and 9, and 1 out of 3, 4, 5. Okay. So this is 1 here. Where is 1 in row 6? 1 cannot be here or here, because on this line can only be 1, 2. 1, 2, and 3 cannot be there. And this line already has a 1, so this must be 1 here. 2 cannot be here, 2 cannot be here, whereas 2 in box 4 can't be on this because of the no repeats on the line, so it must be here. So that's 2. 2 has to be one of these 2 here in row 4, which means where is 2 in column 5? Can't be here because 2's in the boxes have to be here and here. So then 2 has to be one of these 3. Again, how does this add up? Can you ever have a 9 here? So 1, 2, 3, 6, 9. 1, 2, 3 adds up to 6, plus 6 is 12, plus 9 is 21. But this is at minimum not on the line. Sorry, maximum not on the line is 5, 7, 8 in that case. So this cannot be 9. Therefore, this has to be 8, which forces this to be 9. So there's no 9 here. There's no 8 here. So one of these 2 is a 9, and one of these 2 is an 8. Okay. That means we're missing 9 on this diagonal. Can this ever be 5? 1, 2, 5, 6, and 8. If that's the case, so if this is 4 or 5, that would mean we're missing 3 and 7 and 9 at maximum. 3, 7, 9 adds up to 19. 1, 2, 8 already adds up to 11, plus 6 at minimum and 4 at minimum is 21. So that's too large. So this has to be a 3. So this is guaranteed to be 3 here, which means this cannot be 3. 1, 2, 3. So then we know that's 3. So this is 3, which means this cannot be 3 here. This is 4 or 5. Remaining digits on this line are 4 through 9, 4 through 9, 4 through 9, and 4 through 9. This can't be 9. This can't be 6 or 9 because of 6 or 9 in the rows or columns. No 7, no 8. Okay. So can you have 1, 2, 3, 7, 8? Is that possible? 6 plus 7 plus 8 is 21. That would leave you at maximum off the line 5, 6, and 9, which is 20. So the answer is no. So this must be 6 here and 9 here. So we have 1, 2, 3, which is 6 plus 6 is 12 plus 8 is 20. Off the line, we have guaranteed 7 and 9. So that must add up to 20. And then 20 minus 7 and 9 is 20 minus 16, which is 4. So 4 must also be off the line, so this has to be a 5, which eliminates 5 in the rest of the box, and the rest of the line, and the rest of the row. So no 5 here. No 5 here, no 3 here, because of digits on the line. This adds up to 15, so the digits off the line must add up to 15. Therefore, this is a 7-8 pair here. This 5 eliminates 5 on the line, so these can't be 5. So this is 6 and 9, 7, 8 as a pair. 1 is on this line. 2 is not here or here. 2 could be on the line here. This can't be 8, 6, or 9. Okay, so what digits can be here? It can be 3, 4, 5, and 7. It cannot be 8 because we're guaranteed an 8 in one of these cells. We're guaranteed a 9 in one of these two cells. So we have 3, 4, 5, 7. The other 4 digits is at minimum 2, 3, 4, 5. Okay, so this is 7, 8, and this is 7, 8, and they both see that cell, and they're different 7 and 8s because there's no repeats on this line. So this cannot be 7 or 8. This can't be 7 or 8 because of the same reasoning. Okay. Can this ever be 3? 3 plus at most 8 cannot add up to 2, 4, 5, 6 at minimum. So this cannot be 3 here. Can this be 4? 4 and at most 8 is 12. 2, 3, 5, 6, which is the minimum of digits not on the line, would be 2, 3, 5, 6. Can you have a 2 on this line, would be another question. If you have a 2 on the line, then the 4 digits not on the line is at minimum 3, 4, 5, and 6, which is 18, which 2 digits can never add up to. 2 unique digits cannot add up to. Therefore, 2 cannot be on this line. 2 has to be off the line. So 2 is one of these two here. Can you have 3 be on the line? Then the minimum of the digits off the line are 2, 4, 5, and 6. And that adds up to 17, but this cannot be 8 or 9. Neither of these can be 9. This is at most 15. Wait, okay. That's interesting. So the minimum of digits not on the line is 2, 3, 4, 5, which adds up to 14. Therefore, these two digits must add up to at least 14. But 5 plus 8 at most is never going to add up to 14. It's 13. It's too small. So this must be a 7. This has to be 7, and this has to be 8 to add up to more than 14. That means 7 cannot be on this line here, which means this is a 4-8 pair, which eliminates 4 and 8 on the rest of the line. So this becomes a 7-9 pair, which eliminates 7 and 9 on the rest of the box. So this can't be 7. This is 1. So these add up to 22 each on the line and off the line. So this is 7. That forces this to be a 3-5 pair in the rest of box 4. 6 has to be one of these two. Where is 1 in column 6? Can't be here because of 1's in the boxes. Can't be here because of 1 on the line. Can't be here because this has to be 6, 7, 8, and 9 on the line. So this has to be 1 here. 1 eliminates 1 here and 1 here, and this can't be 1 on because of 1 on the line. So 1 has to be one of these two. Where is 1 in column 8? It must be one of these two. And where is 1 in box 1? Cannot be here or here, so it must be one of these two in column 3 and row 3, which eliminates the 1 in row 3, so this must be a 1 there. 1 cannot be here, 1 cannot be here, so 1 has to be one of these 3. That's not helpful. 2 cannot be on this line, 2 has to be one of these 2. Oops. One of these 2. We know 2's there, 2's there, 2's there. 7 eliminates 7 here. This can't be 7 or 8 because of 7 in the column and 8 in the box. So this adds up to 15, which means the digits not on the line must also add up to 15. So there are 4 digits, and I think it has to be 2, 3, 4, and 6. So this must be a 5, 9 pair here. Yep, 2, 3, 4, 6 is the only, without a 1, that's the only way to have 4 digits add up to 15. If they're unique, that 5, 9 pair eliminates 5 and 9 in the rest of the box. This can't be 5 or 9. How did we know that? Because this sees both 7s and 8s, right? These are different 7, 8s, and they both see that cell. So this cannot be 5. This has to be 4, which means eliminate 4 here. So this is 5, which eliminates 5 in the rest of the line. And we know that that sums to 9, so 9 cannot be on the line. So this cannot be 9. This 5 eliminates 5 here, so this is 3, which eliminates 3 here, so that's 5. Remaining digits in box 2 are 2, 4, and 6. So we got 2, 4, and 6 here. This cannot be 2 here. This cannot be 4 there. 4 eliminates 4 on the rest of this line, so no 4 here, no 4 here. We have a 3, 7, 8 triplet on this diagonal, so this can't be 3, 7, or 8. It must be 5. That eliminates 5 here, so that's 9, which eliminates 9 here, so it's 5. We have, so 5 has to be one of these two in column 1. In column 6, it must be one of these two. 5 cannot be here or here, so 5 in box 6 has to be one of these two. Okay. 9 has to be one of these two in row 8. Cannot be here, cannot be here. So this must add to 22. This cannot be 1, 2, or 3, so we have 4 through 9 there. These digits cannot be 1, 2, or 6, so we have 3, 4, 5, 7, 8, and 9. This cannot be 3 or 9 or 5 because of 3 and 9 in the rows or columns and 5 in the column. This can't be 5 or 7. Okay. So we know this adds up to 22 because 22 times 2 is 44 plus 1 adds up to 45, which are the digits either not on this line or already on the line. Okay, so that's probably where we're gonna have to. Okay. What are the remaining digits in row 2? we have here cannot be 1, 2, 3, 5, or 7, so it's 4, 6, 8, and 9. This can't be 1, 5, 6, 7, so we have 2, 3, 4. It cannot be 2 because one of these is 2 here. So 3, 4, no 5, 6, 7, 8, or 9. Okay. So again, these 4 digits add up to 22, and so are the digits that are not on the line. Okay, what happens if you have 2 there? 22, that means the other remaining digits, the other 3 digits must add up to... not sure. Okay, one thing we do know on this line is that a 7 has to be here or here. And 8 has to be here or here. So 7's here or here, which means this can't be 7. So this is guaranteed to be 4 or 8. So we know one of these is a 7. This digit cannot be 7 or 8 because it sees both this line, this cell, and this cell. So it can be 2, 3, no 1, 4, 5, 6, no 7, 8, or 9. So that's 2, 3, or 6. This digit cannot be 7 or 8. This digit cannot be 7 or 8 because they both see those. So this has to be 1 through 4, and then 6. 1 through 4, and then 6. No 6 here because of 6 in the column. No 1 here because of 1 in the column. We know 8 has to be one of these 2. 6, unfortunately, could be here, here, or here, so that's pretty broad. 8... Can you have another 4, 8 here? Maybe? If you have another 4, 8 here, that's 12. Plus 6 is 18. That would require another 4, so that doesn't work with 6. If you have another 4, 8 here with 2, 4 and 8 add up to 12 plus 2 is 14. So the answer is no. You cannot have another even digits in these cells, right? Because these are both guaranteed to be even. Just because of the digits that are available, right? And this 7 eliminated that 7. So these are both even. 2, 4, 6, 8 only adds up to 20. So therefore, if you have one even there, this must be even to add up to an even sum, which it has to be because it has to add up to 22. So this cannot be even. So this is not 4, 6, or 8. This is not 4 or 8. It's 3 or 9 here, and this is 5, 7, 9 here. 22. 5 and 9 add up to 14. So this is going to, that's interesting. This adds up to 2 and 4, 6, 4 and 6, which is 10, 2 and 8, which is 10, or 6 and 8, which is 14. So we add up to 6, 10, or 14. So if we have 6 here, that would mean this would have to add up to 16, so it would be 7 and 9. If we have 10 here. That means this would add up to 12. So it could be 3 and 9. Cannot be 5 and 7. So, okay, what are the possibilities then? So 2, 4, that's 6. 22 minus 6 is 16, so this would have to be 7, and this would be 9 in that case. If we have this adding up to 10, which could be 2, 8, or 4, 6, 22 minus 10 is 12, and it would have to be 3 and 9 here. If this adds up to 14, 6 and 8, 22 minus 14 is 8, and this would have to be 3 and 5. Okay, well, we just went through all the possible combinations, unfortunately. Not helpful. Okay. Hmm. Okay. Remaining digits of... Oof. Which ones do we do? Let's... Let's just go through order. Row 4. We have 2, 4, 5, 7, 8. So this can't be 5 or 8 because of 5 or 8 in the column. This can't be 2, so it's 4, 5, 7, 8 there. Row 5, we have 3, 4, 6, 8, 9. No 9 here because of 9 in the column. No 4 here, no 3 here, no 6 here because of 6 in the box. Row 7. We have 1, 2, 3, 6, 7. Okay. No 7 here. No 1 or 2 here. No 1 here. No 1 here. 3, 6, 7. No 6 here. Okay. 8. Oh. Where is 8 in box 8? Can't be here, can't be here, because there are 8s in the row and column. Can't be here because it sees different 7 8s here. So this cannot be 8 here, no 8 here, because this sees both 7 or 8s, and these must be different. So 8, it has to be here, which makes this 7, which eliminates 7 in the rest of the line, and 7 in the rest of the box, and 7 in the rest of the column. So this cannot be 7 and 9 here. So I think we're guaranteed... No, it doesn't have to be. It could be 3 and 5 here. So this is 7, this is 8. This is 3, 8 as a pair then, and they both see that cell, and they have to be different digits, so this cannot be 8. This is 4, which eliminates 4 here, so that's 8. That means 8 cannot be any of these digits here. Remaining digits here are 2, 3, 6, and 7, but cannot be 2, because one of these two digits has to be a 2. 4 eliminates 4 here. This eliminates 8 here, eliminates 8 here. So one of these two is an 8 also. Okay, rest of row 6 have to be 3, 5, 7, 8, and 9. No 5 or 9 here because of 5 or 9 in the column. No 7 here because of 7 in the column. No 8 here or 3 here because 3 and 8 in the column. This can't be 5 because of 5 in the column. No, 8 here because of 8 in the column. Hmm. We know this can't be 2 and 4. It could be 2, 8, 6, 4, or 6, 8. Wait, this can't be 9 ever. I think it has to be 3, right? So the only way that this was 9 was if this was 7 and 9, right? With 2 and 4 to add up to 22. But we know that can't be there because of 7 in the column here. So now this adds up to 10, and this adds up to 12, which makes that 3, 9. Or this adds up to 14, and this adds up to 8, which is 3, 5. So this is guaranteed to be 3 no matter what, which eliminates 3 in the rest of the box and row. So no 3 there. So 3 has to be one of these two. That also eliminates 3 in the column. So this can't be 3. No 3 here. No 3 here. Where is 3 in row 2? Can't be here because this 8 eliminates 8 here also. But 3 can't be here anymore. 3 can't be on the diagonal because we have a 3. Can't be here because of 3 in the box. Can't be here because of 3 in the column. Can't be here because of 3 in the column. So 3 has to be here. So this is 3, which makes this 8, which makes this 7. That eliminates 7 in the rest of the box. This eliminates 8 here and 8 here. So where is the 8 on the line? It has to be here. So this is 8 here, which eliminates 8 in the rest of the row. 8 has to be one of these two. We have a 5-9 pair now in column 7, which eliminates 5 and 9 in the rest of the column. This can't be 9. It's 4, which means this can't be 4. It's 6, which means this can't be 6. It's 9. That eliminates 9 in the rest of the box. And where's 3? 3 cannot... The only place 3 could have been was these two, and this can't be 3, so this is 3 here. Which eliminates 3 in the rest of the column, so this becomes a 6-7 pair, which eliminates 6 and 7 in the rest of the column and the rest of the box. So there is... Where is the 7 then in row 7? Can't be here because of 7 in the column. Can't be here because of the 6-7 pair in the box. Can't be here because of 7 in the box, so 7 has to be here. So this is 7, which makes this 6. That eliminates 6 here. This 7 eliminates 7 in the rest of the column. So this can't be 7 here. This is 9, which makes this not 9. That's 7. 9 eliminates 9 here, so this is 3 and 5. 3 and 5. 4 eliminates 4 here, so this is 8. 3, 5, and 8 add up to 16. 22 minus 16 is 6. So that's 6, which makes this 4, which makes that 2, which makes that 4, which makes that 7. That makes this 5 and that 2. This can't be 4, 8, it's 5, which eliminates 5 here, so it's 9. 7 eliminates 7 on the rest of the diagonal, so this can't be 7 here. Okay, no 3 here because of 3 in the column. Where is 8 in box 9? Can't be here or here because of 8's in the column. Can't be here or here because of 8's in the row, so 8 has to be here. We have 8 8's now. We know where the last 8 has to be. It has to be here, which conveniently gives us where 5 and 1 have to be, because those were the only other places. This was the only other place 5 and 1 could have been. So 5 is there. That gives us 9 5's. 1 is here. And we don't know. This could still be... So this 4 eliminates 4 here. Okay, so that's 6, which eliminates 6 on the line, so that's 4. That means this can't be 6 here. We have a 1, 2 pair in row 7, which eliminates 1 and 2 in the rest of the row. This can't be 2, so it's 3, which makes this 2. This can't be 2 or 3, so that's 6. 4 here eliminates 4 here. Eliminates 4 here. So this is 2 or 3. Remaining digits in box 9 are 1, 2, 3, 4. This cannot be 1 or 2 or 4 because of 1, 2, 4 in the column. So this is 3, which makes this 2, which makes this 1 and this 4. 1 eliminates 1 here, so that's 2. 2 eliminates 2 here, so that's 3, which makes this 2 here. 4 eliminates 4 here, so it's 9. This can't be 6 or 9, it's 4. We should have a decent amount of stuff. Yes, okay, so 1, we have 8 ones. We know the remaining 1 is here. 2s. We have 1, 2, 3. We have 9 2s. We have 8 3s. We know where the last 3 has to be. It has to be there. 4s. We have 8 4s. We know where the last 4 has to be. It has to be there. 5s. We have 9 5s. We don't have a lot of 6s. I guess we do. We know this has to be a 6 because it's the only place for it in box 3, and we have 8 6s now, so we know where the last 6 has to be. It has to be there. 7s. 7 in column 2 cannot be here because of 7 in the row, and this is the only space remaining, so it's 7. We have 8 7s now. We know where the last 7 has to be. It has to be there. 8s. We have 9 8s, and the rest should be 9s. So this is a 9 here and a 9 here. Very interesting concept. It's basically kind of like combination of arrows with cages, but you have the digits outside the cage adding up to the same sum as the digits in the circles. It's interesting. Is it challenging or is it hard? The logic behind it wasn't that hard. Execution-wise, actually, I don't think it was that hard. So challenging probably is appropriate for this difficulty level. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.